Hello and welcome to G Fun Facts Online, the show that dives deep into the science of our world. I'm your host, and today we're talking about something you've probably felt but maybe never put a name to. Have you ever been walking down a city street on a hot summer day, and it feels like you've stepped into an oven? Then, you turn a corner into a park, and suddenly, the temperature drops. It feels like you've found a little oasis. That feeling isn't just in your head. It's a real, measurable phenomenon called the urban heat island effect. It's the simple fact that our cities, our concrete jungles, are getting hotter. They absorb and trap heat far more than the natural countryside around them, creating these islands of elevated temperature. The difference can be several degrees, and weirdly, it gets even more pronounced after the sun goes down. With more than half of all people on Earth now living in cities, and that number only going up, figuring out why this happens and what we can do about it is one of the most critical challenges we face. So today, we're going to unpack the urban heat island effect. How exactly do our cities cook themselves? What are the consequences of living in these urban ovens? And most importantly, how can we cool them down? Let's get into it. The urban heat island effect isn't caused by one single thing. Instead, it's a perfect storm. A recipe for retaining heat created by the very way we build our cities. Let's break down the ingredients. The number one driver is what our cities are made of. Think about a natural landscape. It's full of grass, trees, soil, and water. These things are nature's air conditioning system. They provide shade, and they perform something called evapotranspiration. That's a fancy word for a simple process. Plants release water vapor from their leaves, which actively cools the air around them. It's like a natural wide-area misting fan. Now, contrast that with a city. We've replaced the soil and plants with asphalt, concrete, brick, and dark roofing materials. These materials are the opposite of nature's air conditioners. They have what's called a low albedo. Albedo is just a measure of how much sunlight something reflects. A perfect mirror would have an albedo of 1, and something perfectly black that absorbs all light would have an albedo of 0. The classic example is wearing a black t-shirt versus a white one on a sunny day. The black shirt absorbs way more sunlight and gets much hotter. Our cities are essentially wearing a black t-shirt. Dark asphalt roads can absorb up to 95% of the sun's energy that hits them. All that energy, all that heat, gets stored in the concrete and asphalt. These materials have a high thermal admittance, meaning they are great at soaking up heat and holding onto it for a long time. So all day long, the city is just baking in the sun, absorbing and storing heat. Then, when the sun goes down, it slowly starts to release all that stored energy back into the air. This is why the temperature difference between a city and the surrounding countryside is often greatest at night. The countryside cools off quickly, but the city keeps radiating heat for hours, preventing any real relief. The second major ingredient in this hot city recipe is the sheer lack of that natural air conditioning we talked about. The loss of trees and green space is a huge problem. A single large tree can provide a cooling effect equivalent to 10 room-sized air conditioners running for 20 hours a day. They provide shade, which is simple but incredibly effective at keeping surfaces cool. And they perform that evapotranspiration, actively cooling the air. A study in Manchester, UK, found that just increasing the city's green cover by 10% could be enough to offset the 4 degrees Celsius temperature rise projected for the city over the next 80 years. Yet, we're going in the opposite direction. According to the U.S. Forest Service, American cities are losing around 36 million trees every single year. We're systematically removing our most effective, natural cooling systems. Next up is the very shape of our cities. The tall buildings packed closely together create what scientists call the urban canyon effect. Picture a street with tall buildings on both sides. It's literally a canyon made of concrete and glass. Sunlight beats down into this canyon, and instead of reflecting back out into space, it bounces between the buildings. Each bounce gives the surfaces another chance to absorb that energy. It's like an incredibly efficient heat trap. These tall buildings also act as a massive wall, blocking wind. In a more open landscape, breezes would help carry away hot air through convection. But in an urban canyon, the air becomes stagnant and just sits there, baking. The geometry of a city has a massive impact. In hot climates like Madrid, traditional architecture featured narrow streets to maximize shade. In colder climates like Helsinki, they built wider streets to maximize sun exposure in the winter. We need to think that strategically about how the shape of our cities affects their temperature. The final ingredient is us. All of our activity generates a massive amount of what's called waste heat, or anthropogenic heat. Think about it. Cars, buses, factories, industrial processes, and especially the heating and cooling systems in our buildings. Cities consume over 75% of all global energy, and a huge chunk of that energy is ultimately released as heat directly into the city air. Air conditioning is the perfect example of a vicious feedback loop. We feel hot, so we turn on the AC. The AC unit works by pumping the hot air from inside our apartment out into the street. This makes the street, and the city as a whole, even hotter. This increased outdoor temperature then makes our AC units work even harder, consuming more energy and pumping out even more waste heat. Studies have shown that this waste heat, particularly from HVAC systems, can raise nighttime temperatures in a city by as much as 1.3 degrees Celsius, all on its own. So you have heat-absorbing materials, a lack of natural cooling, a heat-trapping geometry, and a constant injection of waste heat. It's a powerful combination that turns our cities into furnaces. So okay, cities are hotter, but why does this matter? What are the real-world consequences of living in a heat island? This isn't just about a little bit of summer discomfort. The ripple effects are serious and impact our health, our wallets, and the environment. The most direct and dangerous consequence is on public health. Extreme heat is a silent killer. High temperatures can lead to everything from dehydration and heat exhaustion to life-threatening heat stroke. The people most at risk are always the most vulnerable: the elderly, young children, and people with existing heart or respiratory problems. The urban heat island effect makes heat waves exponentially more deadly. That lack of cooling at night is particularly dangerous. It means our bodies don't get a chance to rest and recover from the heat stress of the day. A study in Europe found that the mortality risk from the urban heat island effect was comparable to the risk from air pollution. It's a major, and often overlooked, public health crisis. Then there's the strain on our energy grids. As cities get hotter, the demand for air conditioning skyrockets. It's a predictable relationship. Research shows that for every half a degree Celsius increase in temperature, electricity demand for cooling goes up by about 1.5 to 2%. It's estimated that a whopping 5 to 10% of a city's total electricity demand is used just to fight against the urban heat island effect itself. This puts an immense strain on our power grids, especially on those sweltering summer afternoons when everyone turns their AC to full blast. In the worst cases, this can lead to brownouts or even total blackouts, which can be catastrophic during a heat wave. This increased energy demand also has serious environmental consequences. To meet that peak demand, power plants, many of which still run on fossil fuels, have to ramp up production. This means more air pollutants like sulfur dioxide and nitrogen oxides, and more greenhouse gas emissions like carbon dioxide, which in turn contributes to global warming. It's another one of those vicious cycles. Furthermore, the high temperatures in cities act like a chemical accelerator for the formation of ground-level ozone, which is the main ingredient in smog. Smog is terrible for our lungs and can trigger serious asthma attacks. The heat even pollutes our water. When rain falls on a hot city, it hits scorching pavement and roofs. This water heats up significantly before it runs off into our local streams, rivers, and lakes. This thermal pollution can be a massive shock to aquatic ecosystems, harming or killing fish and other wildlife that are adapted to cooler water temperatures. Finally, there's the economic toll. all of these consequences come with a hefty price tag. We see increased healthcare costs for treating heat-related illnesses, which one study estimated could be as high as $20 billion a year in the United States alone. We see lost productivity because it's simply too hot for people to work effectively. And of course, there are the higher utility bills for all that extra air conditioning. Another study of European cities calculated the average annual cost of heat island-induced mortality to be around $210 per adult resident. Researchers suggested the total economic losses from high temperatures could be 2.6 times higher in cities, specifically because of the amplifying effect of the urban heat island. Okay, this all sounds pretty bleak. Our cities are cooking us, making us sick, straining our infrastructure, and costing us a fortune. But the good news is, the urban heat island effect is not an unsolvable problem. We created it with our design choices, and we can uncreate it with smarter ones. There are some incredible strategies that can help us cool our concrete jungles. One of the most promising is the use of cool pavements. This is exactly what it sounds like. Instead of using black asphalt that soaks up the sun's energy, we can use paving materials designed to reflect more sunlight. This can be done with reflective coatings, by using naturally lighter materials like concrete, or by using permeable pavements that allow water to seep through and cool the surface through evaporation. The results are impressive. Studies have shown that cool pavements can have surface temperatures that are 5 to 9 degrees Celsius cooler than conventional black asphalt. Cities are already starting to experiment with this. Phoenix, Arizona, for example, ran a pilot study coating residential streets with a reflective sealant to see how it affected neighborhood temperatures. The next, and perhaps most obvious solution, is to bring nature back into our cities. Greening our urban spaces is a fundamental and powerful way to fight the heat. Planting more trees is a no-brainer. They provide shade and cool the air through evapotranspiration. But it's not just about planting a few trees here and there. We need large-scale urban planning that creates and protects parks and green corridors. Interestingly, the shape of these green spaces matters. Research shows that large, squarish parks are more effective at cooling than a bunch of small, scattered patches of green. Another amazing innovation is the green roof. This means covering a rooftop with soil and vegetation. A green roof provides incredible benefits. First, it insulates the building it's on, drastically reducing the need for air conditioning inside. But it also cools the air around the building. A green roof can be up to 30 degrees Celsius cooler than a traditional black tar roof, and it can lower the surrounding air temperature by as much as 11 degrees Celsius. Plus, they come with a host of other benefits, like managing stormwater runoff, improving air quality, and creating new habitats for birds and insects. Ultimately, tackling the urban heat island effect for good requires a complete shift in how we approach urban design and planning. We need citywide policies that encourage or even require the use of cool materials in new buildings and renovations. We need zoning regulations that mandate a certain amount of green infrastructure for new developments. The city of Chicago, for example, has a green permit process that fast-tracks and reduces fees for construction projects that incorporate strategies like green roofs and permeable pavements. Smart planning can also optimize the layout of a city to maximize natural cooling. This means designing streets and buildings to create wind corridors that improve ventilation and ensuring public spaces are designed with plenty of shade for the hottest times of the day. The urban heat island effect is a serious challenge, a direct result of how we've built the modern world. But it's also a challenge we have the power to solve. By understanding the causes and embracing these innovative solutions, from reflective roads to living roofs, we can start to transform our concrete jungles. We can turn these urban ovens into cooler, greener, and more sustainable oases for everyone who lives in them. It's a future that is not only possible, but essential. That's all the time we have for today on G Fun Facts Online. Thanks for tuning in. Join us next time as we explore another fascinating piece of our world. Until then, stay curious.